This. So today is 3/6/17, and this is the 5A FIP quiz solutions because there was sufficient confusion that whiteboarding doesn't help. So we have a rock on a hill, and the hill's at a 30-degree angle. The rock has a mass of 43.8 kilograms, and we are told that the work done by gravity is equal to 5.30 times 10 to the 4th joules. What we want to know is how far the rock rolls. What's the distance? So the thing to be careful with here, you guys at this point, after chapter 4, good Lord, you're all really good at looking at breaking up the force of gravity onto two axes. So we have force of gravity straight down, and then we have F of gy, and we have F of gx. Of those two, which one does work on the rock? F of gx. F of gy does nothing on the rock. So we have to take our good old work equals FD cosine theta and look at which part of that force that's being applied by gravity is doing work. Well, it's FGX. So work done by gravity equals FGX d cosine theta. Okay, so we've got that. Now we're solving for the distance. Great. So we can say then that the work done by gravity divided by the FGX cosine theta equals distance. Notice that I kept that cosine theta in there, and we're going to talk about why, and this is the part that I realized wasn't clear. So FGX, of course, is, let's see, work done by gravity. That's mass gravity times the sine of 30 degrees. Okay. Where does that cosine theta come in? Well, there we're looking at the angle between the force that's doing the work and the work that's being done. Which direction is the rock rolling? Down the hill. Which direction is the force being applied? Down the hill. The angle between the direction that the rock is moving and the direction that FGX is 0 degrees. So that is cosine of 0. Now you might think that's dumb. On number 3, you're going to see where it's not dumb. Yeah, you just got it. You just got it. So let's plug in a number. Okay, so we've got 5.3 times 10 to the 4th divided by 43.8 kilograms times 9.81 meters per second squared times sine of 30 times cosine of 0. What we get as a raw answer is 246.6963 blah, blah, blah is the distance. Now, whoever wrote this problem obviously believes that somewhere there is a hill that goes on at a constant angle of 30 degrees for 246 meters. That's one heck of a hill at a constant slope. With sig figs, we get 247 meters is the distance. Okay? Questions, comments, concerns? Based on that, do you want to take a minute and try to redo number 3, part A on your own? Because I think right now, having just seen that, you could probably all do number 3 and get it correct. Why don't you do that? Why is it cosine 0? It's cosine 0 because the angle between this force and the distance that it's moving is 0. So it's all about the angle between the force that's being applied or the force that's doing the work and the axis on which it's moving. All right, let's do number 2. Kid in a box. Tiny little kid in a box. In a crate with a winch to the ceiling. This sounds like it could be a Dr. Seuss book. So we have, again, work equals FD cosine theta, and that we're looking for force. So work divided by distance, cosine theta equals force. And in this case, of course, again, the winch is pulling the box and the kid straight up. The kid and the box are moving straight up. So the angle between the force and the displacement is 0. Ready to pick it up. So work divided by d cosine theta equals the force exerted on the poor little kid who you put in a box. What are you doing, you monster? 4.60 times 10 to the fourth joules divided by 9.50 meters times cosine of what? 0, which is 1. And so what we get is 4,842.105263 newtons, bam, equals your force. When you sig fig that out, you end up with 4840. I cannot make this shrink to save my life. Yes, you end up with 4840 newtons is the force. And pretty much everybody got that right. That one was the low-hanging fruit. Okay, so we have a 23 kilogram box being pushed up a completely frictionless incline that does not exist. Angle of 15 degrees, and it is pushed 6 meters is what it travels, we're told. I'll just put that up there. And I gave you 6.0, so we'll use that for sig figs. What is the work done on the crate by the pusher? So this is part A, and this would be the work of the pusher is equal to the force exerted by the pusher times the distance the pusher pushes the object times cosine of the angle between the force exerted by the pusher and the motion. So if we do our standard operating thing here and tilt the axis and just say that the slope of the incline is now our x-axis, and it's moving up that axis, what's the theta between the force being applied and the motion? 0. Cool, that's easy. And we actually want to know what the work done is, so we don't have to solve for anything. The force applied by the pusher is 175 newtons. Distance is 6.0 meters, and that would be cosine of 0. So what we get as a raw answer is that the work done by the pusher is equal to 1,050 joules. Is that what you got when you redid it? Awesome. And that sig figs, who's the crazy person who only gave you 2 sig figs? What a pain in the tuchus. 1.1 times 10 to the third joules. Dang it. 5s are tough. All right, so now we have part B, which is the tougher part. The work done by gravity on the box. So the work done by gravity is going to be equal to the force of gravity times the distance the box moves times cosine of the theta between the distance that it moves and the direction in which the force is being applied. Is all of the force of gravity doing the work? No. Just the gravity on the x. So force of gravity, work done by gravity equals F of gx times d times cosine of the angle between the work being done by gravity and the motion of the box. What's the angle between the work being done by gravity and the motion of the box? Okay, what do you think? What do you think it is? Go. You. No, it's not. No, it's not 0. So let's look at this. Which direction is gravity working on it? Down the slope. Which direction is it moving? Up the slope. It's 180. 180. So the work done by gravity equals mass, gravity, sine of 15 times, times d times cosine of 180. What is the cosine of 180? -1. It just makes your work negative. Because, of course, gravity is doing negative work on the box. The pusher's doing positive work on the box. Gravity's doing negative work on the box. All right, plug in. Okay, we've got our plugged in stuff. And that gives us then work done by gravity is equal to -350.3840 blah, blah, blah joules. If we sig fig that out, we get -350 joules.
What about the
Gravity?
Would that be negative as
Well,
well?
and I'm using the whole sort of new understanding of just calling the magnitude, just calling G 9.81 and assigning direction as required. But here we know that the work has to be negative. Questions, comments, concerns? Really, really easy. There was just a piece missing from your understanding. So, all right.